All right, so there is a geometric pattern that exists on the base 12 Cartesian plane or the diagonal Cartesian plane that enables us to understand what an irrational number is a little bit more clearly. So we know that pi is an irrational number. So what that means is when we divide the diameter of the circle into the circumference, there's always going to be a little bit of an extra space left over. So that's what an irrational number is. It's a number where when you have a numerator and a denominator in a division situation, no matter what combination of numbers you use to try to divide one into the other, there's always going to be a little bit of space left over. So our current model of that type of number is basically just a long string of what we're calling infinite digits that almost get to the end of that solid line, but never quite close that gap or that little remaining space. And so we just say, well, it goes to infinity, and then that's it. So instead, what occurs on the base 12 Cartesian plane is the ratio is revealed as to basically how you do it is you take that solid line and you divide it into the circumference, but that empty space is dispersed throughout the circumference. So every little piece of that overall line has that empty space built into it. And then it all works out perfectly. Then you can line it up and create a diagram for 360 degrees. You can take those little pieces, individual units of pi, basically, and work with them as if it was a rational number. So this is what it looks like. You have these two bits of the solid line. You can see they're all joined together there. And then there's a little gap between them. So that enables us to create that type of a pattern where the lines are going outwards, sort of like a degrees. Or you have this bottom part here where you turn it and then you create a ring that has a little bit of thickness to it. So that's what I'm going to do now is show you how we create this diagram. We take that basic geometry, then just keep creating more and more rings so the circle gets larger and larger. And on the 30th ring, we have 360 of these little circles, and we are able to divide the circle perfectly into 360 degrees. And then we realize, well, we can just keep going. So we're going to look at how to do that. I'm going to show you how to do that, create that diagram using this geometry in the next few videos.